Consider that an ideal gas n moles is expanding in a process given by V is equal to f of V, which passes to the point V0 P0. Show that the gas is absorbing heat at P0 V0 if the curve P is equal to f of V has larger slope than that of adiabatic, which is passing through P0 V0. Let us assume the equation for the process P is equal to f of V as PV power n is equal to C, and for adiabatic we know it is PV power gamma is equal to C. So for our actual process, dP by dV actual is going to be C into minus n V power minus n minus 1, whereas for adiabatic dP by dV will be equal to C into minus gamma V power minus gamma minus 1. If the slope of the actual curve is larger at the point V0 than the slope of adiabatic, we can say minus n V power minus n minus 1 is greater than gamma V power minus gamma V power minus gamma minus 1. So from this, n V power minus n minus 1 is less than gamma V power minus gamma minus 1. This case is only possible when n is less than that of gamma. Now let's see what is the work done in the process of PV power n is constant. So delta W for the process PV power n is constant is given to be P0 V0 minus PF Vf by n minus 1. This is a derived expression where P0 V0 are the initial state pressure and volume, and PF Vf are the final states pressure and volume. From this, delta W actual is equal to V0 minus Vf Pf by n minus 1. And let's also calculate the change in internal energy in this process. Delta U actual would be equal to NCV Tf minus T0, and for ideal gases Cv is equal to R by gamma minus 1. Therefore, the change in internal energy in the actual process is going to be Nr by gamma minus 1 into Tf minus T0. So this is equal to 1 by gamma minus 1 into nRTF minus nRT0. nRTF and nRT0 can be replaced by PFVF and P0V0. So the final expression is going to be 1 by gamma minus 1 into PFVF minus P0V0. So this is the expression for the change in internal energy in the actual process, which we have assumed it to be PV power n is constant. From the first law, delta Q will be the sum of change in internal energy and the work done by the process. So this is going to be equal to PFVF minus V0 P0 by gamma minus 1 plus P0 V0 minus PFVF by n minus 1. So this is going to be P0 V0 minus PFVF into 1 by n minus 1 minus 1 by gamma minus 1. Initially, from the slopes of both the curves, adiabatic and the actual process, we have found out n is less than gamma, and if n is less than gamma, the term 1 by n minus 1 would be greater than 1 by gamma minus 1. As this term is greater than, as 1 by n minus 1 is greater than 1 by gamma minus 1, delta Q is going to be positive. So delta Q is going to be positive means that the heat is supplied to the system for going from initial state to the final state.